In the early 1940s, when American physicists were experimenting with nuclear energy for the Manhattan Project, the US government knew it had to take extra precautions to keep researchers safe. They then created a health division. One of the team members, Ernest Woolen, focused his time on measuring radiation exposure. As a result, Woolen developed the film badge dosimeter, the first ever reliable device to track a worker's cumulative exposure to ionizing radiation. Before Woolen and his team created the film badge dosimeter, the only way to measure a worker's radiation dose exposure was by using a pocket ionizing chamber, which was prone to error. Tubes the size of a fountain pen, they store an applied electrical charge affected by radiation. When a person measured the initial charge and the final charge, it would be determined how much radiation exposure has occurred. The pocket chambers were awkward to use and only measured individual doses at a specific time, not the cumulative dose over a period of time.
In the world of occupational safety, precision is paramount. Today, we'll introduce you to a revolutionary tool that has transformed the way the world monitors radiation exposure, the optically stimulated luminescence, or OSL. The OSL consists of a filter holder case that is home to plastic, aluminum, copper, and also the detector palette. The OSL is made out of aluminum oxide doped with carbon, which is sensitive to ionizing radiation. When exposed to ionizing radiation, the detector traps electrons in its crystalline structure. And to protect the filters, it is then inserted in a slide where they stay protected from the light. The OSL is sent back to the dosimeter lab to undergo reading and annealing by OSL reader. A small LED light stimulation illuminates the OSL and releases the trapped electrons as visible light. The luminescence signal is counted by a photomultiplier and the personal dose is calculated using an algorithm. The intensity of the light is directly proportional to the radiation dose received during the wear period. Wear your dosimetry on the front of your body and facing out. If a uniform is worn, ensure it is in close proximity but not covering your personal dosimeter. Its compact size and reusability make it a convenient and essential tool for any worker exposed to radiation.
Now it's the time. Are you ready to explore the future of dosimetry with us? But wait, let's do some recap on how OSL is so useful when applied to radiation worker. One is definitely stable sensitivity. Reusable of course for this high-cost little device. And a high speed of readout even at room temperature. The studies of advanced and improving dosimeters has been carried out for decades even until today. We will be looking into each aspect, so make sure how your seatbelt tied. Rules number 1 is there must be a compromising when we have a high sensitivity means there is a low detection of heavy charged particle. Maybe let's understand this. Detection of a neutron is very specific that the neutrons are not directly ionized and usually have to be converted into charged particles before detection. And guess what? According to the research paper by E.G. Yukihara and others, has identified high sensitivity has a lower neutron sensitivity. But the paper has also proposed the use of neutron converters directly to produce a new OSL dosimeters. Sounds cool? Let's see what other features might be available. The possibility of using neutron converters itself has produced a new neutron-sensitive OSL composite material identical to aluminum oxide doped with carbon dosimeter. The characteristics are high optical sensitive and long-lived luminance lifetime. Dosimeters are all about detection, so keeping flat dose and energy response constant, that is definitely important to decrease the risk of underestimating dose to radiation stuff. So what did the study done? Based on the current finding, this can be achieved by one keyword, combine. Other than the theoretical application of OSL dosimeter, improvements can be done on the physical application too. Introducing to you an enhanced accumulated dose measuring and monitoring system. It is applied mobile and the most importantly, miniature photoelectric sensor that reduce in size and easy to carry around. It is still able to detect the instant when the dosimeter needles arrives at a specific dose set point. Setup of audible alarm with the time interval check able the workers to be conscious of their assigned stay time and watchful of the dose. This feature is believed to develop a raise of the level of safety by reducing the risk of overexposure while enable improved concentration on work tasks for all radiation workers. And here is all the sharing of the future pathway that OSL dosimeter might develop into in the future. Hope you can get the beneficial from our presentation.